Hello and welcome back to this channel. Dear students, this topic is directional couplers. Actually, from the exam point of view, you may expect the question like draw and explain the two-hole directional coupler, or it may be asked like this: define the particular parameters of the directional coupler along with its S matrix, or you may expect the numerical related to directional coupler. First, let us discuss the basic working of a directional coupler. As the name indicates, it is a coupler. That means power from one waveguide can be transferred to another waveguide, and it is directional. That means transfer of power takes place in a particular direction. So it is a 4-port device, port number 1, 2, 3 and 4 as shown in this basic diagram. Suppose we'll apply certain input power at port 1, then this power passes from port 1, it reaches up to port 2, as well as there is a hole in between this. So the power can well pass through this gap and it enters into the another, let us say this is one more waveguide. So it is available also at port 3. That means if the input power is applied at port 1, output will be available at port 2 and port 3, but this power will not be available at port 4. That means when input is applied to port 1, port 4 is not coupled because output is available only at port 2 and 3. If, let us say, we will apply the power at port 4, then similar to that of port 1, if power is applied at port 4, then this power transfers to port 3 as well as to port 2, but this power will not transfer back to port 1. This is the basics of directional coupler. Now, this diagram shows two-hole directional coupler. Actually, the concept is, suppose this is the waveguide, let us say it is main waveguide. Now, certain power is passing through this main waveguide. I want to transfer part of this power to some another waveguide, let us say that is auxiliary waveguide. So this auxiliary waveguide is kept like this. That means it is bent and certain holes are created. Through these holes, the power gets transferred from main waveguide to the auxiliary waveguide. This is the concept of two-hole directional coupler. These two holes are lambda by 4 apart. Lambda is the wavelength. So actual diagram is as shown in this figure. It consists of this main waveguide. This is the portion of main waveguide. Upper part is auxiliary waveguide. So let us say this is main waveguide, this one is auxiliary waveguide. In between these, two holes are created, hole A and B. These two holes are separated by a distance lambda by 4, where lambda is the wavelength. Now, one of the ports, actually there are 4 ports, just now we discussed. One port is terminated with matched load. If there are any reflections, a backward wave, if it is passing, then it should be blocked. So one of the ports is terminated with matched load. Now let us say forward wave is moving, coming from this direction. Then this wave, forward wave passes from left to right. It will be available at this port. But part of the wave gets transferred through hole A, as well as some part gets transferred to hole B, and added power, that means part of the wave, part of the power which is moving in this direction like this, part of the power gets transferred through hole A, as well as some part gets transferred to hole B, and these two portions gets added, and in the auxiliary waveguide you are getting some output. So this is the case when forward wave is applied, but there may be certain reflections. So let us say there are reflections from this port, and reflected wave is, as the name indicates, it is in the backward direction. So part of this reflected wave, actually reflected wave has to pass from right to left, but portion of reflected wave passes through hole B, remaining portion passes through hole A. Actually this is the terminated matched load. So whatever reflected wave that is entering in auxiliary waveguide through hole A, through hole B and through hole A, it will appear like this. It will start moving towards right hand side direction. But observe this diagram carefully. What I said, this is the reflected wave, portion of reflected wave is passing through hole B and remaining portion is passing through hole A. But this distance is lambda by 4, and when these two waves are getting combined, then we can easily say the wave passing through hole A has to travel a distance lambda by 4 from this point to this point. Again from this point to this point, again additional distance is lambda by 2. So total distance becomes lambda by 2. That means the wave entering through hole A and reaching up to this point, point B, 180-degree phase shifted. That means if I'm talking about the wave passing through hole B and coming at this point, and the wave which is moving like this from RHS, then enters through hole A into this another part and gets traveling in this direction, has to travel distance lambda by 2. So these two waves, one reaching directly from lower part to the upper part through hole B, and another coming following this path, that means through hole A and again coming back. These two waves are 180-degree phase shifted, so these two waves gets cancelled. That means there is no effect of reflected wave. So this is the working of two-hole directional coupler. Now let us discuss few important parameters of the directional coupler. Just now we discussed the concept of two-hole directional coupler. Just to make this thing simple, I will brush up the things once again. In case of two-hole directional coupler, there is a main waveguide. This is the main waveguide through which actual microwave power is transmitting. We want to take out part of this microwave power in some another waveguide, that is auxiliary waveguide. So auxiliary waveguide is bent like this and two holes are created. One end of the auxiliary waveguide is matched load. I mean it is terminated in a matched load just to avoid the effect of reflected power. Then these two holes are lambda by 4 apart. That means distance between the two holes is lambda by 4. Now first parameter, कपलिंग पैरामीटर. अब देखो ये डेफिनेशंस आप लोगों को मगअप करने की जरूरत नहीं. इफ यू जस्ट रिमेंबर दिस सिंपल फॉर्मूला यू विल बी इन अ पोजीशन टू राइट द डेफिनेशंस ऑन योर ओन. सो कपलिंग फैक्टर इज डिनोटेड बाय C. Everything is expressed in, every parameter is expressed in decibels. So it is 10 log ratio of P in upon P auxiliary. PAUX stands for auxiliary power. So it is the ratio of input power to the auxiliary power. That means whatever power is applied at the main waveguide to the power available in the auxiliary waveguide expressed in dB, decibels, gives the value of coupling factor. In terms of S parameter, it is S14 or S41. This parameter, coupling factor, gives amount of attenuation in the output power. Second parameter is directivity. It is denoted by D. It is 10 log P auxiliary in the forward direction, ratio of P auxiliary in the forward direction to P auxiliary in the reverse direction. That means it is the ratio of auxiliary power in forward direction to the auxiliary power in backward reverse direction. In terms of S parameters, it is S34 or S43. If the value of D is high, that means higher value of D indicates less leakage power in the auxiliary arm. Third is insertion loss. As the name indicates, if the direction coupler is inserted in the main waveguide, then there are certain losses associated with it, which is the insertion loss. It is denoted by L and it is 10 log of P in upon P transmitted. That means ratio of input power to the ratio of transmitted power. Because 100% input power will not get transmitted, there will be certain losses. That factor is given by this parameter insertion loss denoted by L. Next is isolation loss. Isolation loss is denoted by I. It is 10 log P in upon P auxiliary in the reverse direction. That means it is the ratio expressed in decibels, ratio of input power in the main waveguide to the reverse power in the auxiliary waveguide. Now this is the generalized S matrix of the directional coupler. As we discussed, there are 4 ports. So this matrix is of the size 4 rows and 4 columns. S11, S12, S13, S14 up to S44. Now make the thing simple. There is a perfect matching. That means S11 is equals to S22 is equals to S33 is equals to S44 is equals to 0. So all these elements S11, S22, S33, S44 are written 0. Then there is a no coupling between port 1 and 3. That means S13 and S31 is equals to 0. So these parameters S31 and S13 are made 0 in this matrix. Similarly, there is no coupling between 2 and 4. So S24 and S42 is equals to 0. So these things S42 and S24 are made 0. Don't get confused. Just while explaining the basic part, I have given certain names: port 1, port 2, port 3, port 4. You can well interchange the names. There won't be any effect. So this is the S matrix for the directional coupler. Now let us solve few numericals related to this directional couplers. First problem is a scattering matrix of directional coupler is, this is the given scattering matrix. Find directivity, second part coupling factor, third isolation, and fourth return loss. We already discussed the definitions and meaning of each and every term. As far as the numericals are concerned, do remember you just have to know these formulae. It's pretty simple. If you know the formulae, just put the values, you will get the answer. But for the reference purpose, I have written the S matrix of directional coupler. These are the generalized notations we already discussed. S11, S12, S13, S41 up to S44. Now first part, directivity. Formula is 10 log mod of S13 square upon mod of S14 square. So this is 10 log and this is square. So it becomes 20 log mod of S13 upon mod of S14. Do remember these values are like this. For example, first value is 0.05 at an angle 30 degrees. So this part 0.05 indicates magnitude. That means this particular part is mod of S11. Likewise, we want mod of S13. So this element represents S13. Corresponding element in the given matrix is this one. So it becomes 20 log 0.1. Magnitude means you just have to skip the angle part. So it is 20 log 0.1 upon mod of S14. S14 is this term, that is last term. So upon 0.05. So if you solve this, answer is 6.020 dB. Second is the coupling factor. It is minus 20 log of S13. S13 is this part, this element, that means the same what we discussed right now. So it is minus 20 log of 0.1, that is 20 dB. Third, isolation. Formula is minus 20 log mod of S14. S14 is the last element, that means this. So minus 20 log of 0.05. By default, log is to the base 10. Sorry. So minus 20 log to the base 10, 0.05. So answer is 26.020 dB. And last is return loss. Return loss from the output towards the input side. So it is minus 20 log of mod of S11. S11 is this part. So minus 20 log of 0.05, that is 26.020 dB. So this is the way to solve the numericals related to parameters of the directional coupler. Next numerical, a symmetric directional coupler with infinite directivity and forward attenuation of 20 dB. So this is the given value of attenuation, which is 20 decibels, is used to monitor the power delivered to load ZL as shown in figure. This is the given diagram. So here ZL represents the load. This part at the LHS we have connected one generator. Two bolometers are shown which are used to take the measurement of power. So bolometer 1 introduces VSWR. VSWR is voltage standing wave ratio of 2 on arm 4. These are arms 1, 2, 3, 4. So on arm 4, VSWR is 2. Then bolometer 2 is matched to arm 3. If bolometer 1 reads 8 milliwatt, that means this bolometer gives the reading of 8 milliwatts and bolometer 2 reads 2 milliwatt. This bolometer reads 2 milliwatt. Find first part amount of power dissipated in ZL. Second part VSWR on arm 2. Now listen carefully. This is tricky numerical. I have to draw the generalized flow, power flow diagram. So this is the generator. Then two bolometers are drawn, B1 and B2. We'll discuss how these values are written. Values of power that we need to calculate. So this is port 1, port 2, port 3, port 4. These ports are written. The port numbers are written according to the given diagram. This was the given diagram. This diagram we need to draw in the exam to show the flow of power. Now, reflection coefficient. This is the notation somewhat similar to the English letter T. So reflection coefficient, you may well use the notation K for reflection coefficient, no problem. So reflection coefficient, the formula is rho minus 1 upon rho plus 1, where rho is the VSWR. VSWR, this value is given, which is 2. So 2 minus 1 upon 2 plus 1, that is 1 by 3. This is the value of reflection coefficient. Now, there are two important parts. P plus indicates incident power and P minus indicates reflected power, which is in backward direction. These two powers are related as P minus, that is reflected power, is equals to P plus incident power mod of reflection coefficient square. Now, next part is given attenuation is 20 dB, which is given in the question. This is given in dB. If I want to convert it in normal units, then it is, let us denote attenuation by A. So 10 log of A is equals to 20. 20 is the given value. I need to calculate the value of A. So if I will transfer this 10 at the RHS, it becomes log A is equals to 20 by 10, that is 2. So A is antilog of 2. Antilog means 10 raised to 10 raised to 2, that is 100. So attenuation is 100. That means corresponding ratio is 100:1. This is the power ratio. That is the ratio of incident and reflected power. Now, this reflection coefficient can be expressed in terms of reflected and incident power as reflection coefficient, which we have calculated this value as 1 by 3, is square root of P minus upon P plus. P plus is incident power. Incident power is forward power and reflected power. Now refer the question. This bolometer 1 reads the forward power. We will discuss how these values are written. This bolometer reads the reading 8 milliwatt, but there is always a reflection. So this is 8 milliwatt. Now I have to refer this formula. So see, 1 by 3 is square root of P minus upon P plus. So P bar upon P plus. So it is P minus upon 8 plus P minus, because as I said, this bolometer reads 8 milliwatt and some portion is getting reflected. So it is actually 8, that is the reading by this bolometer B1, plus P bar. P bar is the P bar or P minus is the reflected power. So formula square root of P bar upon 8 plus P bar. Take square on both sides, you will get 1 by 9. This square root will get vanished. P bar upon 8 plus P bar. So take cross multiplication. 8 plus P bar is equals to 9 P bar. This gives P bar is equals to 1. That means reflected power is 1 milliwatt. So this reading is 8 milliwatt. Reflected power is 1 milliwatt. So actual power reaching at bolometer is 9 milliwatt, because it reads 8 milliwatt and 1 milliwatt is getting reflected. So here I have written 1 milliwatt, and this reading I have written 9 milliwatt because this is 8 milliwatt and out of which 1 milliwatt is getting reflected. So this value is written as 9 milliwatt. Now P1, that is incident power at port 1, is 100 times P4 plus. See, this is port 4. Just now we discussed the power ratio is 100:1. So this value is 9 milliwatt. 100 times this value you will get at port 1 because of this power ratio 100:1. So at port 1, P1 is 100 times P4 plus, that is 100 times 9 milliwatt. So it is 900 milliwatt. P2 minus, that is the power which I have shown by the blue ink. this power which is getting reflected from port 2, this power, that is P2 bar or P2 minus, is 100 times. Again, we are referring power ratio 100:1. 100 times 1 milliwatt, because 1 milliwatt is the reflected power. So it is 100 milliwatt. That's why I have written this reading as 100 milliwatt. Now, this bolometer 2 reads the value 2 milliwatt, which is given in the question, that bolometer 2 reads 2 milliwatt, out of which 1 milliwatt is reflected. That means, since this value is 2 milliwatt, 1 milliwatt is reflected power, so 1 milliwatt is the power passing through the holes. Now, power dissipated in ZL, simple formula, P2 plus minus P2 bar or P2 minus. So it is 900 minus 100, that is 80 milliwatt. That much power is amount of power dissipated in ZL. Answer of first part. Second part, VSWR on arm 2, simple formula, 1 plus mode of reflection coefficient upon 1 minus mode of reflection coefficient. We know that value of reflection coefficient is 1/3. So 1 plus 1/3 divided by 1 minus 1/3, answer is 2. So this is the way how to solve the numericals on directional couplers. So dear students, that's it for today's session. So thank you. Thanks a lot for watching this video.